Right. So, so far we discussed, right? So far we discussed about plane mirrors. So some of the things that we have learned on last days will be revised here as well. So we on the last day we discussed how the light rays would get reflected and an image could be formed uh, on a plane mirror, right? So we basically discussed two ways of how light gets reflected from a plane mirror, and even when you place a point object in front of a plane mirror, how would it forms an image? That's what we discussed on the last day. So basically, what you have to understand from here is plane mirrors are these smooth surfaces, like you have a linear surfaces on plane mirrors, okay? And when you talk about some other sources of mirrors, we have to talk about curved mirror as well. Curved mirrors as well, right? When we talk about curved mirrors, we have two types of curved mirrors, right? Concave, right? Concave mirrors are these, right? So this is the type of the concave mirror. So what I'm marking with these slanted inclined lines, what I marked here is the unnecessary surface or the useless surface of the concave mirror. So light is coming into a cave. If the light seems to be coming inside a cave, we call that sort of a curved mirror as a concave mirror. Okay, so the next one is convex mirror. Okay, next one is convex mirror. So when you talk about the convex mirror, the opposite of the concave is the convex. The opposite of the cave is a convex. So light rays would be reaching the mirror like this. Okay, so keep it in your mind. There are two types of curved mirrors, concave and the convex. If the light rays are seen to be going inside a cave, that's a concave mirror. The opposite of that is convex. Okay, so when you talk about these, I wanted to mark it here, right? See here, I have given you already the two types of curved mirrors here. Then I just want you all to mark it over here. Can you see that I've given it again? But the thing is, I've not mentioned the surfaces of them, the necessary surfaces and the unnecessary surface. See here, I want you to mark it over here. So mark it. Okay. So mark it. This is the unnecessary surface of this mirror. And the light ray should be coming into the mirror like this. It has to be a straight line. Don't make it a line like that, right? I'm using the mouse, that's why the lines are not so straight. Right? So the light should be coming to the surface of the mirror like this. Concave mirror and convex mirror. So I wanted to mark the two surfaces and mark how the rays coming to these mirrors. Right. Okay. Did you all mark it? Girls and boys? Lamai, respond me. Do you mark it?
Yeah,
Yeah.
sir.
Okay, perfect. Right. So afterwards, so we are going to talk about few things about this concave and convex mirrors, right? Okay. So now listen, how to form a concave and a convex mirror. How to form a concave and a convex mirror. It would be like this. Okay. Now see here. I'm gonna take a sphere, a glass sphere. Let's say I'm gonna take a glass sphere. Okay. Right. This is a glass sphere. Okay, a glass sphere. Okay, so what I'm gonna do then, I'm gonna what do you call, apply. I'm gonna cut a part of this, cut this part actually. I'm gonna cut this part of the glass sphere. Okay, I would double line it to indicate that is the part of, that I'm going to cut from the sphere. This is the part that I'm going to cut from the sphere. Okay, and then I'm going to uh, apply some mercury on this side. Let's say I'm going to apply mercury on this side. So you can see a concave mirror is formed. So what did I do? I actually obtained a glass sphere, and then I cut a part of it, and then I applied mercury on this side of the concave mirror. So obviously this side of the uh, Okay, right. So then this side of the concave mirror becomes smooth and shiny and a reflective surface. Okay, so then that's what happens when happens when I take a glass sphere and paint to apply mercury on this side. The opposite side, this side becomes a smooth, shiny, and reflective. Okay, so then you can see that I have made a concave mirror. So then the next thing I'm gonna do, I'm gonna separate this part of the sphere. Okay, I'm gonna separate this part of the sphere. I'll just be erasing it. I'm gonna separate this part of the sphere. Okay, and then I'm gonna apply mercury on the inner side. And then I'm gonna apply mercury on the inner side. So then this surface becomes very smooth, shiny, and it becomes reflective. Right. Put up your hand, those who can understand up to this. Right. Hold on. Paper. Paran me. Class miss Ready? Right. So this is the way how you form a concave mirror and a convex mirror using a glass sphere by applying mercury or whatever. So then you can make one surface of them reflective, right? So then I just want to read it through. Someone needs to help me. Shanuki, can you help me here? Can you read this part?
Yes, so from there are two types from that.
Yeah, that's done. That's done. This part, what I have highlighted.
The center of each sphere to which the mirror surface belongs is called the center of curvature.
Center of curvature. Of the mirror.
Symbolized as C.
C. Okay. Now, if you can remember, right? I hope you know how to construct a circle, right, or a sphere, right? So, if you can remember that, you should know that you have to keep the compass at the middle of this circle, and then you have to draw it as a circle. So, the center of this sphere is this. Center of this sphere is this. Okay. I would mark it. Center of this sphere is somewhere over here. Let's say. Okay. So this is called capital C, or the center of the curvature. Center of the curvature. Okay. Center of the curvature. Now clearly see here. Now there was a sphere. It had a midpoint, the center, which was called the center of curvature. From that glass sphere, I extracted a part and then applied mercury to make it a concave mirror. And then I extracted another part and applied mercury to make it another convex mirror. So if you can remember, if you can understand, this curved surface and this curved surface, both of them are obtained from the same sphere. So the curveness of this sphere, curveness of this concave mirror goes around this center point. If you can understand, curveness, this curved surface, this curved mirror, this concave mirror, the curveness of this concave mirror goes around this center point. Okay, that means the curvature of this curved surface is arranged around this center point. Okay, so the curveness of this convex mirror also belongs to this center point. Okay, so if I tell you, this curvature, this curveness of this sphere, right? Curveness of this sphere. Hold on, it's like this. What I was telling, both of these curved surfaces are obtained on the same sphere. So because of that, this center point belongs to both of these curves, both of these curved surfaces. That's what I want to tell you. Okay, so both this center point, this center of curvature, belongs to the both of these curved surfaces. Put up your hand, those who can understand that part. What I was saying, Kelly. All right. Okay. Right. Okay. So, okay. Right. Alicia, can you read the next part?
The center of the curved surface of the mirror is called the pole of the mirror.
Hold on, hold on. The center point of the curved surface of the mirror is called the pole of the mirror, right? Okay, hold on, right? Okay, so till now I was talking to you about the sphere, glass sphere, and then I was telling you how to extract a part from it and apply mercury to make it a concave mirror and a convex mirror. And then I told you these two curved surfaces belongs to the same center of curvature, because around the same center of curvature only the both curvenesses are created. Okay, curved surfaces are created around the same center of curvature. So then the next thing what you have to do is I'm telling you to find out the exact middle point of one of these curved surfaces. Okay, so see here. So as you can see here, you have a concave mirror surface here. I want you to find the exact middle point, the midpoint of this concave mirror surface. Okay, it could be somewhere over here, right? That means from this place, the curveness up to here should be equal to the curveness up to here, right? So if I'm selecting the exact middle point of this concave surface, right? From the middle point, the curveness which is over to here should be equal to the curveness over to here. Can you understand that point? Put up your hand those who could understand that point. So I've selected a midpoint over here. I've selected a midpoint of what? This curved surface. I wanted to put your hands up if you could understand it. I'm finding out the midpoint of this curved surface. This curved surface again, exact middle point again. Okay, right. So I'm finding out the exact middle point of this curved surface as well, right? Okay, so I'm going to find out the midpoint of this curved surface as well. It will be somewhere over here. Let's imagine, not it might not be the exact truth, exact points, but let's imagine. We call this point as the pole, or you could even call it as the vertex. You can mark it, okay? So here, this is also called the pole or vertex, okay? So what did you do? You took the exact middle point of the concave mirror and you mark it as pole, vertex of the concave mirror. So you obtain the exact middle point of the convex mirror surface and you named it as the pole or the vertex of the concave mirror, convex mirror surface. Okay, so think I have marked as pole, you can mark it as vertex as well. Okay, so the next thing, okay, Ellie, next part.
The line joining the pole and the center of curvature is called the principal axis.
Okay, so then what do? I draw a line. Okay, I draw a line like this. Okay, I draw a line from the center of curvature up to the pole. This is called principal axis. This is called principal axis. From here also I can draw the same from the point center of curvature up to the pole. This is called principal axis. Can you understand? This part is called principal axis. From here to here, the length from here to here is also called principal axis. Can you understand? So what did I do? I from the center of curvature, I drew a line up to the pole of the convex mirror. That line is called as principal axis. So I could do the same to the other mirror as well. From the center of curvature up to the pole of the concave mirror, I drew a line that's called the principal axis. Are you guys okay with that? People, are you okay with that? Respond then, Ellie, are you okay with that? Right, okay. Right, Upe, Bimsen, Shanuki?
Yes, sir.
Bimsen?
Okay, sir.
Okay, right. Sure, Nether? Bimsen? Right, okay. Right. So then what did I do? Right from the beginning, took a sphere, glass sphere, applied mercury on this side to make it a smooth, shiny surface, to make a concave mirror surface. Then extracted part of the glass sphere like this and applied mercury on this side to make it a smooth surface, to make it a convex mirror. So then what did I do? I exactly marked the midpoint of the concave mirror surface and marked it as a pole of the concave mirror surface. And then I selected the exact midpoint of the convex mirror surface, and then I marked it as the pole of the convex mirror surface. Then the next step, from the center of that, now you had to keep it in your mind, this curved surface was created around the center of curvature. This point only, this curved surface, the convex mirror surface was constructed around the center of curvature. This concave mirror was constructed around the center of curvature. So from that center of curvature, that point, up to the pole of the convex mirror, I drew a line and I name it as principal axis. Okay. So then again, from the center of curvature up to the pole of the concave mirror, I drew a line and then I mark it as principal axis. I hope that it is not marked as principal axis in your diagram. So if you can mark it, that's better, right? Over here. So mark this line, highlight it if you want, and mark it as principal axis. Mark it here and mark it as principal axis. I wanted to make this a concave mirror, make it a concave mirror, and make this a convex mirror. Okay, like what I have done. So mark one as concave mirror and the other one as convex mirror. And from the center of curvature, the line to the pole of the concave mirror is known as principal axis. And again, from the center of curvature, the line which is going to the pole of the convex mirror is also called the principal axis. You got to draw it very quickly. Done. Done. Hello, can you all switch on your mics and speak with me? Hello, lamai. මොකද අද නිකන් නිදිමත සීන් එකේ. මොකද මගේ voice එක හොඳ නැද්ද? I'm sick. ළමයි මොකද සද්ද නැත්තේ අද? චනුකි, එලීෂා, උපේකා, නිර්මාණි මොකද සද්ද නැත්තේ? හෙලෝ, මාව ඇහෙන්නේ නැද්ද ළමයි? ළමයි මාව ඇහෙන්නේ නැද්ද?
ඇහෙනවා සර්.
මොකද බලව එහෙනම් කතා කරන්න නැතුව ඉන්නේ? Right, okay. Elisha, you can read the next point.
The principal axis is perpendicular to the mirror surface.
Okay, the principal axis is perpendicular to the mirror surface. Okay, so you have a problem now. Okay, so can you remember? Okay, can you remember when we were talking about plane mirrors? Okay, when we were talking, now if you can remember, put up your hands, right? When we were talking about plane mirrors, we discussed when you have a plane mirror like this, if a light ray reaches the plane mirror in a way that the incident ray becomes a perpendicular, incident ray incidence on the plane mirror with a 90-degree angle. If the incident ray is perpendicular to the mirror surface, as I told you on that day, that incident ray would get reflected back along the same path. That incident ray would get reflected back along the same path. If you can remember this, put up your hands. When I was talking to you about plane mirrors, I told you if there was a light ray coming perpendicular to the mirror surface, the light ray would get reflected back along the same path if the incident ray strikes on the plane mirror perpendicular. Right, perfect. If you can remember, that's great. Huh? Okay, so can you remember the next situation? Okay, can you remember the next situation? If you have a plane mirror, okay, if you have a plane mirror, and if there was a light ray coming to the plane mirror with an angle, okay, if there was a light ray coming to the plane mirror with an angle, and if it incidents on a point like this, then you have the incident ray you have. So then you have to figure out what would be the reflected ray. Right, you want to figure out what would be the reflected ray. So then what you have to do, you have to do a construction called normal. So this construction has to be started constructing from the point of incident, and it has to be constructed in a way that this normal line becomes perpendicular with the mirror surface. Okay, so we are talking about a light ray which is incident on a plane mirror angularly, and we are in a trouble to find out how would the reflected ray would get reflected from the mirror surface. And then what we have to do, we have to make a small construction called the normal. How would you do the normal construction? You have to start the construction from the point of incidence, and then you have to construct the normal in a way that it finally becomes perpendicular with the mirror surface. Okay, done. And then you have to keep it in your mind, this normal, the construction what you did here has to be in between the incident ray and the reflected ray. Okay, so it has to be in between the incident ray and the reflected ray, obviously. So then what did we do? We did a construction called normal. So then this construction would tell us the angle in between the incident ray and the normal, and that is known as incident angle, I'm sorry, right? So now this construction helped us to figure out the angle in between our construction called normal and the incident ray, and that angle is called incident angle. And this now at this situation, your reflected ray should be going away from the plane mirror with an angle which is similar to the angle of incidence. So then you can just simply figure out an angle which is equal to this incident angle as the angle of reflection, right? So this is how a reflection would be done by a plane mirror if any incident ray is incident on the plane mirror angular. Okay, I'm coming to a point. That's what I'm explaining again. The both of the situation that we have discussed on the last day, right? Because I have a point to talk to you here with regards to those points, right? So those were the two main laws that we spoke on the last day about plane mirrors, right? If there was a light ray coming to the plane mirror perpendicularly, if there was an incident ray coming to the mirror surface, plane mirror surface perpendicularly, the light ray would get reflected back along the same path. And if there was a light ray coming to the surface of the plane mirror angularly, then what do we have to figure out? What do we have to do to figure out the figure out how to draw the angle of reflected ray? First of all, from the start, from the point of incidence, you have to construct the normal in a way that the normal ultimately becomes perpendicular to the mirror surface, and then this normal has to be in between the incident ray and the reflected ray also, and this normal creates the angle in between the incident ray and the normal, which is called the incident angle. So then, as a theory, as a law, that you know, this reflected ray should have an angle which is equal to the angle of incidence. So then what you have to do, just simply take the angle which was similar to the angle of incidence and draw the reflected ray with the same angle. So in this case, we know the angle of incident is equal to the angle of reflection, right? From this theory, we knew in reflection the angle of incidence is equal to the angle of reflection, right? We knew that it was incident angle is equal to the angle of reflection. Now the thing is here. Now this is okay. We know the angle of incidence is equal to the angle of reflection. That's done. Now here, so reflection, wherever it happens, the angle of incidence has to be equal to the angle of reflection. So here, now the problem is what is the concept for us to draw the reflected ray and the incident ray on the same pathway if the incident ray strikes on the plane mirror perpendicular? So you need to have a reason. From that day, I was just telling you, if there was an incident ray coming to the plane mirror surface perpendicularly, the light ray should get reflected back along the same path. But I didn't actually give a reason for that. Why would it happen? But for this, I gave you a reason. Why would it get reflected angularly? Because it follows the incident angle equals reflected angle concept. So then the reflected angle and the incident angle in this situation has to be equal in their magnitudes, right? Now in this case, when you have the incident ray, okay, when you have the incident ray, first of all, when you have the incident ray incidence on the mirror surface, you should do the construction for the normal, right? You should construct the normal, right? See here. Now, how would the normal has to be constructed? It should be starting from the point of incident. Now, imagine that you have only the incident ray, which is striking incidents on the plane mirror perpendicular. That's it you have, right? So I'm going to give you why the reason, but the reason for reflected ray to get back along the same pathway, right? Bouncing back along the same pathway. Why would it get reflected back along the same path? I'm going to give you the reason, right? So if you have this incident ray striking on the mirror surface like this, you need to do the construction called normal. Okay, how would you do? You have to start the construction from the point of incidence, and then you have to do the construction called incident normal in a way that the normal would be perpendicular to the mirror surface. Okay, did. Now you can see the construction normal also lies along the incidence ray. Now, can you actually find out an angle between the incident ray and the normal? Can't. Why? Both of them are the same now. Right now, you only had the incident ray coming towards the mirror surface perpendicularly. So, from the point of incidence, you started constructing the normal. Okay, you started constructing the normal. So, when you started constructing the normal, what really happened? The normal supposed to get constructed along the incident ray, because it has to be started constructing from the point of incidence, and then it has to be constructed in a way that the normal would get perpendicular with the mirror surface. So when you construct it, the normal would lie on the incident ray. So then you will not be able to figure out any angle in between the incident ray and the normal. So angle in between the incident ray and the normal is called the incident angle. No? So here there's no angle. There's no angle between the incident ray and the normal, because normal lies on the incident ray itself. So here in this situation, incident angle is 0. Angle of incidence is 0. So what you have to follow when the reflection is taking place, every time the incident angle has to be equal to the reflected angle. So now here the incident angle is 0. Okay, angle of incidence is 0. So what would definitely the reflected angle should be? Right, incident angle should be equal to 0. No, so this here, if the incident angle is 0, the reflected angle also should be 0. So then, if the reflected angle to be 0, there should not be any distance, there should not be any angle between the reflected ray and the normal. So then, reflected ray also should be going on the same path. Okay, so this was the reason, right? This was the reason for a light ray to get back along the same path if this light ray incident on a plane mirror surface perpendicular. Why? Now the simple concept is we have learned in reflection, every time the incident angle should be equal to the reflected angle. Incident angle is equal to the reflected angle. So in this plane mirror, I only had this incident ray coming towards the plane mirror. Okay, I had it. So figure out to figure out the reflected ray, I had to do the construction called normal. I did the construction called normal starting from the point of incidence. And at the end of the construction, I should see that the normal is perpendicular with the mirror surface. Okay, that. So now I have an angle between the incident ray and the reflected ray. That is called incident angle. Okay. Now in the laws of reflection, the second law of reflection, we know incident angle should be equal to the reflected angle. So then I have the incident angle. I have to create an angle as a reflected angle, which is equal with the magnitude of the incident angle. So then may angle like an equal angle in the light ray should get reflected from the mirror surface. So then, if the light rays are striking on the mirror surface angularly, they should get reflected angularly with the same sort of an angle as the incident angle, right? That is the rule. So in this concept, we come again to this concept. You have a plane mirror. The light ray was coming to the plane mirror as it was going to strike on the plane mirror perpendicularly, and then they are asking us to figure out how the reflected ray would be. How? Now you have to construct the normal. You have to start the construction of the normal from the point of incidence. Okay, you do the construction from here to here, and then finally the normal is perpendicular with the mirror surface. Okay, done. Now you see the incident ray and the normal are on the same line. So like before, now you can't figure out any angle between the incident ray and the normal. Angle, there's no angle. Both of the lines are same. So incident angle here should be 0. Okay. Incident angle here is 0 because incident ray and the normal lies on the same line. So incident angle is 0. So according to the laws of reflection, incident angle should be equal to reflected angle. So if the incident angle here is 0, the reflected angle here also should be 0. So then reflected ray also should travel on the same path in a way that the reflected ray have no gradient, have no angle in between the normal and the reflected ray, right? So that was the reason for this light ray to get back along the same pathway. If you understood my explanation, put up your hands, please. It was a tough one, I know. It would be tough a little bit. Okay, Vincent, Shanuki, okay, Elisha. Okay. Elisha, was it difficult? Upe, was it difficult? Right? You had no reason. You had no reason for that. Them, right? And let's think about the second situation. Can you remember? If there was an incident ray coming to the mirror surface angularly light ray kakawut mirror surface. Okay? And your problem now is how to create the reflected ray. Kohen the reflected ray ka yanne. To understand that, you need to do the construction called normal. Over the construction called normal like hadanne. අපිට ඔය construction එක පටන් ගන්න වෙන්නේ light ray එක mirror surface එක strike කරපු තැන. That's what we are calling as point of incidence. Point of incidence එකේ ඉඳලා normal එක construct කරනවා මම. Normal එක construct කරලා ඉවර වුණාම this normal has to be perpendicular with the mirror surface. මේ normal එක perpendicular වෙන්න ඕන mirror surface එකකට. දැන් ඔයාට හම් වෙනවා an angle. What is that angle? Angle between the normal and the incident ray. Angle between the normal and the incident ray. Me angle එකට අපි කියනවා incident angle කියලා. Angle between the incident ray and the normal. අපිට laws of reflection වලදී second law එකේ උගන්වනවා reflection එක වෙනකොට incident angle එකට equal angle එක තමයි reflected angle එක reflected light ray එක යන්නේ කියලා. එහෙනම් now you have a clue. Reflect වෙලා යන light ray එක should have an angle which is equal to the reflected angle. ඔතෙන්ට නිකන් තේරුණාද කියන්නේ කට්ටියට? එලි හරිද? එලි දැන් මොකද තාත්තේ?
Okay, sir.
උපේ එක දැන් හරිද?
Yes, sir.
Okay, so what is this angle between the incident ray and the normal? Incident angle. Angle between the reflected ray and the normal? Reflected angle. Reflection එකක් වෙන වෙලාවේ incident angle එක reflected angle එකට equal වෙන්න ඕන. ඔක තමයි reflection වල second law එක. දැන් අපි යමු මේකට. Okay, so you have the incident ray. Incident ray එකක් තියෙනවා. දැන් ඔයාට කියනවා draw the reflected ray. ඔයා ඒක කරන්න කලින් ඉස්සලාම normal එක construct කරගන්න ඕන. So how to construct the normal? Starting from the point of incidence. On the point of incidence එකේ ඉඳලා පටන් ගන්නවා normal එක construct කරන්න. Normal එක construct කරලා ඉවර වෙනකොට මොනවා වෙන්න ඕනද? Normal එක mirror surface එකත් එක්ක perpendicular වෙන්න. Right, මම මේ normal එක construct කරා. කරලා බලනකොට මේ incident ray එක දිගේම තමයි normal එක construct වෙන්නේ. දැන් එලීෂාට හරි උපේකට හරි මට හොයලා දෙන්න පුළුවන්ද මේ එකම line දෙකක් උඩ නම් තියෙන එකම line එක line එකක් උඩ නම් ඊළඟ line එක තියෙන්නේ ඒ line දෙකේ angle එකක් තියෙනවද? To create an angle there should be a deviation, right? These two lines called construction called normal and the incident ray are overlapping on each other. එතකොට would there be an angle between the two lines? Respond me, Eli.
No, sir.
Upe. No. එහෙනම් මෙතන incident angle එක කීයද? 0 because incident ray එක උඩින්ම තමයි normal එක යන්නේ. එතකොට මේක එහෙම නැහැ. incident ray එකයි normal එකයි වෙනස්. Incident ray එකේ ඉඳලා normal එකට you had an angle. Here or normal එක construct කරපුවාම normal එක construct වෙන පාර දිගේම තමයි incident ray එක ඇවිල්ලා තියෙන්නේ. Okay, එතකොට there's no angle between the reflected incident ray and the normal. Can you understand, Elisha?
Yes.
Okay, reflection law says incident angle has to be equal to the angle of angle of incidence has to be equal to the angle of reflection. Then එතකොට මෙතන incident angle එක 0. එහෙනම් මට කියන්න ළමයි reflected angle එක මොකක් වෙන්න ඕනද? angle of reflection මොනවා වෙන්න ඕනද? උපේ එලි මෙතන incident angle එක 0 නම් angle of reflection මොනවා වෙන්න ඕනද?
0.
0. එහෙනම් reflected ray එකයි normal එකයි අතරේ angle එකක් තියෙන්න බෑ නේද? දැන් මේකේ theory එක ගත්තාම ඔයාලට incident angle එකයි reflected angle එකයි අතර angle එකක් incident ray එකයි normal එකයි අතර angle එකක් නැහැ. angle එක 0. According to the laws of reflection, incident angle එක 0 නම් reflected angle එකත් ඒ value එකම වෙන්න ඕනේ. incident angle equal reflected angle, incident angle එක 0 නම් reflected angle එකත් 0ම වෙන්න ඕනේ. එහෙනම් දැන් ඔයා අඳින reflected angle එකයි normal එකයි අතරත් angle එකක් තියෙන්න බෑ. හරිද? එහෙනම් මට reflected angle ray එක අඳින්න වෙන්නේ normal එක උඩම තමයි. කතාව තේරෙනවද?
Yes, sir.
Okay, that's why you call when you have a light ray coming to the mirror surface perpendicularly, the reflected ray also goes back along the same path. Because when the light ray strikes on the plane mirror perpendicularly, incident angle එක 0. එහෙනම් ඒ වෙලාවේ reflected angle එක 0 වෙන්න ඕනේ. එහෙනම් light ray එක ආපු line එක දිගේම යන්න ඕනේ. Are you guys clear with this?
Yes, sir.
Okay, so
Yes,
then
sir.
if you are clear with this, you have to go to this part. Sorry, you have to go to this part where we this here. Can you remember this is the place where we drew this plane mirror into which the light ray strikes perpendicularly, right? And you marked here incident ray strikes on the plane mirror perpendicularly, the reflected ray would also go in the same pathway. So for this, the reason is here the incident angle equals 0. So according to the laws of reflection, the reflected angle here also should be what? 0. Mark it and circle it here. Now only you came to know the reason why this reflected ray would get reflected back along the the reflected ray gets reflected back along the same way if the incident ray strikes on the plane mirror perpendicularly. Okay, so now you know the reason now. A light ray would get reflected back along the same path if it strikes on the plane mirror perpendicularly. Now you have the reason. Done with that, shall we move on? Lama, shall we move on? Hello.
Okay.
Right, okay. Eli, can you read the next part? This part?
For light rays coming along the principal axis, the incident angle is 0. Therefore, the angle of reflection is also 0. So the light rays get reflected along the same path.
Okay. හරි ඔන්න බලන්න. දැන් මේකේ කියනවා මේ ඕනම curved mirror surface එකකට if there was a light ray coming along the principal axis, the incident angle එක 0. ළමයි මට ඔයගොල්ලෝ කියන්න what do you call this line in maths? What do you call this line in maths? කවුරු හරි පටස් ගාලා මයික් එක on කරලා කියන්න.
Radius.
Radius. That's what you call it in maths. මට ඊට පස්සේ කියන්න මෙන්න මෙහෙම එකක්. ඔයාලා මේ construction එහෙම කරලා තියෙනවා නේද? geometrical construction එහෙම කරලා තියෙනවා නේ? මට කියන්න ඕගොල්ලෝ ඉගෙනගෙන තියෙනවද this radius line starting from the center of curvature of a circle, මේ radius එක ගිහිල්ලා circumference එක touch වෙන තැන 90 degree angle එකක් හැදෙනවා කියලා අහලා තියෙන කට්ටියට උත්සාහ එහෙම අහලා තියෙනවා නම් අත උස්සන්න. ශානුකී අහලා තියෙනවා. right. බිම්සෙන් අහලා තියෙනවා. right. දෙන්නයි අහලා තියෙන්නේ. මේ center of curvature එකේ ඉඳලා යන radius කියන line එක circumference එක touch කරන තැන හැදෙන්නේ perpendicular එකක්. අහලා තියෙන්නේ ඔය දෙන්න විතරයි. right. මට ඕගොල්ලෝ I'm just asking right. ඕගොල්ලෝ circles අඳින විදි කීයක් දන්නවද? obviously number 1 method එක compass එකක් තියලා compass එකක් තියලා මුග්ගා ලැන්දා right number 1 ඊට පස්සේ කවුරු හරි කියන්නේ circle එකක් කොහේ හරි කපලා තියලා cardboard එකේ ඒක වටේට අදිනවා හරි right okay number 2 තව anybody know any other method to draw a circle right okay හරි අහගන්න මෙන්න මෙහෙමත් කරන්න පුළුවන් right පැන්සලක් අරගෙන හොඳ sharp pencil එකක් අරගෙන පැන්සල බෝඩ් එක මේ කොලේට මෙහෙම මේ ඇඟිල්ල මෙහෙම තියන්න ඕන කොලේට right මෙන්න මෙහෙම ඇඟිල්ල තියන්න ඕන මේ දැන් මේ පැන්සල මෙහෙම අල්ලගෙන ඇඟිල්ල මෙන්න මෙහෙම කොලේට තියලා මෙන්න මෙහෙම සර්කල් එකක් එන්න හැකියි මෙන්න මෙහෙම සර්කල් එකක් එන්න හැකියි right ඇඟිල්ලේ මෙන්න මෙහෙම right මම ඔක පොඩක් කරලා දානවා කියලා තියන්නේ මේ රෙකෝඩින් එකක් දාන්නම් right එහෙමත් එන්න හැකියි ඔක තව විදියක් තවත් තියෙනවා විදිහක් සර්කල් එකක් අඳින්න මෙන්න මෙහෙමයි ඩොට් එකක් තියෙනවා මෙහෙම ඩොට් එකක් තියලා ගන්නවා රූලක් ඩොට් එක පේනවා ඇතිනේ ඩොට් එකක් තියලා ගන්නවා රූලක් හරිද රූල අරගෙන මේ ඩොට් එකේ එජ් එකට තියලා ගහන ස්ට්‍රේට් ලයින් එකක් හරිද ඊට පස්සේ පොඩ්ඩක් කර්ව් කරලා ඔයාගේ ඩොට් එකේ එජ් එක වටේට කර්ව් කරලා තවත් ගහන ස්ට්‍රේට් ලයින් එකක් ආයි පොඩ්ඩක් කර්ව් කරලා මෙහෙම ගහන ස්ට්‍රේට් ලයින් එකක් ඔය වගේ ස්ට්‍රේට් ලයින්ස් 300ක් 400ක් ගැහුවොත් අර ඩොට් එක වටේට ස්ට්‍රේට් ලයින් 300ක් 400ක් විතර ගැහුවොත් ඔයාට අල්ටිමේට්ලි එනවා මෙන්න මේ වගේ රවුමක්. ඕක දැනගෙන හිටපු කට්ටිය අත උස්සන්න. අම්මේ මන් දන්නේ ඔයගොල්ලෝගේ මැත්ස් ටීචර්ස්ලා මොනවද උගන්වන්නේ කියලා. කටපාඩම් කරනවා මැත්ස් උත්නේ. හරිනේ? right? එතකොට ළමයි ඔය මං ඇඳපු ස්ට්‍රේට් ලයින්ස් ගොඩෙන් එක ස්ට්‍රේට් ලයින් එකක් ගත්තොත් ඔය මං ඇඳපු දැන් ඔහොම ස්ට්‍රේට් ලයින්ස් ගොඩාක් ගැහුවාම එහෙම සර්කල් එකක් එනවනේ ඔය සර්කල් එක හදන්න ගහපු ස්ට්‍රේට් ලයින් වලින් එකක් ගත්තොත් ඕකට තමයි ඕගොල්ලොන්ට කියන්නේ ටැන්ජන්ට් එකක් කියලා උගන්වනවා නේද ටැන්ජන්ට්ස් කියලා ටැන්ජන්ට්ස් උගන්වලා තියෙනවා නම් එහෙම එකක් අහලා තියෙනවා නම් අත උස්සන්න මම දන්නේ මේකට සිංහලෙන් කියන්නේ මොකක්ද කියලා ටැන්ජමයක් කියලා කියනවා දන්න right right ටැන්ජන්ට්ස් දන්නවා විමා දන්නවා හරි අනිත් කටේ ටැන්ජන්ට්ස් උගන්වලා නැහැ තාම හරි ඕකේ එතකොට ඔයගොල්ලන්ට ආයෙ උගන්වනවා ටැන්ජන්ට් එකකට center of curvature කියන ඉලක්කයෙන් දහ මේක ඇඳෙන්නේ radius එක. උත්තර හැදෙනවා 90 degree angle එකක්. perpendicular එකක්. හරිද? ඒ කියන්නේ ළමයි අපේ මේ circle එක කිව්වහම circle එක හැදෙන්නේ චූටි minute straight lines millions ගාණක් විතර එකතු වෙලා හැදෙන්නේ වගේ කියන පොඩි idea එකක් ගන්නත් පුළුවන්. ඒක බැරි නෑ right? එතකොට මේ ටැන්ජන්ට් එක කියන්නේ මෙච්චර මෙහෙම දඩාර ටැන්ජන්ට් එකක් ගැහුවට ටැන්ජන්ට් එක එක්සිස්ට් වෙන්නේ මේ හෙන චුට්ටි ඩිස්ටන්ස් එකකට. දැන් ඔයා දන්නවනේ obviously මේක circumference එක curve මිසක් මේ straight line එකක් නෙමෙයි. ඒතකොට curved circumference එක හරිය minute millimeter එකකටත් වඩා අඩු තැනක් තමයි මේ consider කරන්නේ ටැන්ජන්ට් එක ගහලා ලොකුවට තියාගත්තා. එතකොට මේ center of curvature එකේ ඉඳලා මෙහෙම ඉලක්ක ගත්තාම radius එක ඇඳහම ඒ radius එක tangent එකත් එක්ක intercept වෙන්නේ 90 degree angle එක. ඒ කියන්නේ මෙහෙමයි අපි assume කරනවා we assume that this line called starting from the point of center of curvature circumference එකට අඳින line එක ඔයාලා mathematically call it as radius that radius makes a 90 degree angle with the circumference 90 degree angle එකක් මේ radius එක circumference එකත් එක්ක create කරනවා කියලා maths වලදී ඔයගොල්ලන්ට හරියටම උගන්වලා තියෙන්න ඕනේ. ඔතෙන්ට එනකන් කතාව තේරිච්ච කට්ටිය මට පොඩක් අත උස්සන්න. right. okay. හරි. දැන් එහෙනම් මේක චුට්ටකට කලින් අපි කතා කරා if you have a plane mirror and if there was a light ray coming to the plane mirror in a way that the light ray would get incident on the plane mirror perpendicularly මේ light ray එක reflect වෙන්නේ toy path එකේම තමයි කියලා. ඒ කියන්නේ plane mirror surface එකට incident ray එකක් ආවොත් in a way that the incident ray incidence on the plane mirror perpendicularly it would get reflected back along the same pathway because here the incident angle is 0. So the reflected angle has to be also 0. එහෙනම් මේ path එකම තමයි යන්නේ. දැන් බලන්න if there was a light ray coming towards the concave mirror surface along the principal axis. Principal axis එක දිගේ light ray එකක් ආවොත් if there was a light ray coming towards the concave mirror along the principal axis එක දිගේ light ray එකක් ආවොත් මේ light ray එක mirror surface එකත් එක්ක incident වෙන්නේ perpendicularly. ඒ කියන්නේ මෙතනත් incident angle එක 0. එහෙනම් මෙතන තියෙන reflected angle එකත් 0 වෙන්න ඕන. එහෙනම් ඔය light ray එක reflect back වෙන්නේ ඔය පාර දිගේම තමයි. ඔය පාර දිගේම තමයි. So I want you to mark it over here. Right? I want you to mark it over here. See here? It's better if you mark it here. Right? Yeah. මෙන්න මෙතන පොඩ්ඩක් mark කරගන්න ඕක. Right? මෙතන mark කරගන්න. If there was this light ray coming towards the concave mirror along the principal axis, may I reflect back along the same path because here the incident angle equals 0. Therefore, the reflected angle also should be 0. තක්කල mark කරගන්න. අනිත් පැත්තට එහෙමයි ළමයි. දැන් මේ convex mirror surface එක. මේ පැත්ත වැඩක් නැහැ නේ convex mirror surface එක. මතකයිනේ ඔයගොල්ලන්ට මේ පැත්ත වැඩක් නැහැ. හැබැයි if there was a light ray coming along the principal axis, මේ principal axis එක දිගේ light ray එකක් convex mirror surface එකට ආවොත් එයත් perpendicularly තමයි. මෙතන මේ perpendicular mark එක දාන්න perpendicularly. මෙතනත් මේ mirror light ray එකත් this incident ray also would get incident on the plane mirror perpendicularly. So this here also incident angle like a 0. Okay, so the reflected angle is also 0. So this light ray would get reflected back along the same pathway. ඕනම curved mirror එකකට light ray එකක් තියෙනවා නම් principal axis එක දිගේ the light ray is getting reflected back along the same pathway. මොකද principal axis එක දිගේ එන light ray එක right ඔය principal axis එකේ දිගේ එන light ray එක principal axis එකේ දිගේ එන light ray එක curved mirror surface එක touch කරන්නේ perpendicular එකක් එක්ක. ඒ කියන්නේ 90 degree angle එකක් එක්ක. එතකොට මෙතන incident ray එක 0 එහෙනම් reflected ray එකක් 0 වෙන්න ඕනේ. එහෙනම් ආපු පාර දිගේම it should get reflected. Here මේ mirror එකට මේ පැත්තේ light rays දාලා වැඩක් නැහැ නේ. If there was a light ray to come to this mirror surface මේ පැත්තේ මේ light ray එක would get incidence on the plane mirror perpendicularly. Right? එහෙනම් මෙතනත් incident angle එක 0 reflected angle එකත් 0 වෙනවා. එහෙනම් the reflected ray also go back along the same pathway. Right? Mark it. අර මන් දීලා තියෙන diagram එකේ ඔය දෙක mark කරගන්න. important පට්ට important ඔය ටික. ඔන්න අද තමයි ගොඩක් laws derive කරගත්තේ. අපි we have spoken about laws, we studied about laws on the first day, right? Those were very easy at the very first day. Now we have arguments to build upon, right? And then we had to deal with those arguments when we are constructing things hereafter, right? දැන් මෙතනලා අපිට curve mirrors ගැන කතා කරනකොට ඒ වල right rays, how they travel, how they behave, all depends on these laws. හරිනේ? එන එක ඔළුවේ තියාගන්න. ළමයි හරිද? කට්ටිය අද මදියා. අද ඇක්ටිව් මදි. අද මම පටන් ගත්තත් එක්ක පරක්කු වෙන්නෙත් ඇතුළු. හරි ළමයි. ශානුකි මට කියවන්නකෝ පුතේ. එළිය නිදි ගන්න ඉඳන් තව ටිකක්.
So from focal point, focal point of a curved mirror, for light rays coming along the principal axis, the incident angle is 0 because the rays strike the mirror surface perpendicularly. Therefore, the angle of reflection is also 0, so the light rays get reflected along the same path.
Highlight that's very important. You need to highlight it. Okay. Right, next part.
Rays coming parallel to the principal axis towards the concave mirror passes through a point on the principal axis after reflecting the mirror, which is called the focus or the focal point of the mirror.
Okay, I'll tell you about that. Right. So then, we have to see, we have to experience how would the reflection be done by concave and convex mirror surfaces. Okay, hold on, that we have to do it here, right? So when we are drawing that ray diagram, we have to follow up all the rules and regulations and the laws that we learned up so far. Okay, right? So here on the first side you have a convex mirror, and on the other side you have concave, right? Okay, convex on this side, right? Convex mirror. Okay, on the other side concave, right? Concave, right? ඔයා මේක දෙකට බෙදා ගන්නවා නම් that's better. Concave mirror. Okay, because I will be telling you some things also, right? Okay, so this is what we're going to talk, right? Concave mirror එකක් අපි දැන් දන්නවා, right? So I have this concave mirror would be like this. So this is the unnecessary surface of the concave mirror. Okay, so then first of all I'm marking the principal axis with the green marker. May curved mirror surface exactly center එක තමයි we call it as the pole. If you can remember, this middle point, the center point of this curvedness of the concave mirror is called the pole. Okay, so it has to be middle, right? Pole එක මෙතනින් mark කරලා principal axis එක මෙහෙම mark කරන්න එපා. That's wrong. Okay, right? Hope you can understand. It has to be very at the middle, right? At the very middle, right? Okay, right. So this is the principal axis. I would mark it over here, right? Principal axis. Principal axis, I'm marking it over here, right? Now you know one point, right? Now you know one point, that's if there was a light ray to reach the mirror surface through the principal axis, that would definitely get reflected back along the same path, right? If there was a light ray to reach the concave mirror surface along the principal axis, now can you remember that we came to a what do you call okay, lastly, can you remember we decided to mark the incident rays with blue color and mark the reflected rays with red color. So in this case, mark it with pencil. Everything you have to mark the ray diagram, draw the ray diagram with the pencil, and use the blue color pen to mark the arrows of the incident ray, and use the red color to mark the arrows of the reflected ray. Okay, so what I'm telling you now, there's this incident ray coming towards the concave mirror surface along the principal axis. Okay, there's this incident ray coming towards the principal axis, coming towards the concave mirror along the principal axis. That should definitely get reflected back along the same pathway. Okay, so then the heading says what would happen to a parallel beam of light if it falls onto a concave and convex mirror. So to this principal axis, there's another light ray parallel to this principal axis. It has to be a light beam, a parallel light, a beam of parallel light, a beam of parallel rays. So then there's another light ray which is parallel to the principal axis, comes to the surface of the mirror, concave mirror. After that, this light ray gets reflected. Okay, and gets focused on a point called F. That's capital F. We call it as focus. Okay, so that is where the light ray gets reflected after striking on the mirror surface. The next parallel light ray to the principal axis, there's another light ray parallel to the principal axis, reaches the concave mirror surface. After getting reflected, it also goes and gets focused on this point called focus. Okay, so what you can see from here, right? What you can see from here, a parallel beam of light has converged. A parallel beam of light has converged after being reflected by a concave mirror, right? A parallel beam of light rays has converged and actually has got focused on a point on the principal axis called focus after being reflected by a concave mirror. Concave mirror එකකින් reflect වෙලා a parallel beam of light gets converged onto a point on the principal axis called focus. And I'm drawing a dotted line from this pole. The pole dotted line and I'm bringing down another line from this focal point. This length from the midpoint of the curve concave mirror surface to this point F, we call it as focal length, and we symbolize it with the simple F. Don't draw it till I tell you, right? So now you experience what really happened. There was this concave mirror. There was a light ray coming to the concave mirror along the principal axis that actually strikes on the plane mirror perpendicularly. So it has to go, gets reflected back along the same pathway. And there were two parallel light rays coming to the surface of the concave mirror parallel to the principal axis. Those got reflected and got converged at a point called F on the principal axis. So simply concave mirrors can converge a parallel beam of light. Okay. The next thing, we come across convex mirror here. Right, we have a convex mirror. Okay, and then we have to mark the principal axis here as well. Okay. Mark the principal axis here as well. So principal axis has to be principal axis. It has to be starting to construct from the very midpoint of the curved surface. Okay. So if there was a light ray, coming towards the convex mirror along the principal axis, it would get incident on the plane on the convex mirror perpendicularly, and it should get reflected back along the same pathway, no doubt. Okay, then there's another light ray parallel to this principal axis, reaches the convex mirror. Okay, reaches the convex mirror. This light ray, right, gets diverged after the reflection. This light ray gets diverged after the reflection. Okay, the light ray gets diverged after the reflection, and it seems to be down. Now it gets diverged. I'm just erasing it on this side, right? It gets diverged after the reflection, and for a person looking at the light ray got diverged from here, it seems to be coming. It seems to be this light ray is coming from a point inside the convex mirror called F on the principal axis. So you call it as the focus. Okay, if there was another light ray, this is a reflected ray. If there was another light ray parallel to the principal axis, if there was another light ray parallel to the principal axis, right, reaches the convex mirror, that light ray also get diverged and gets reflected. And for a person who is looking at this diverged light ray, he sees that the light ray is coming from a point inside the plane mirror called F. But actually this light ray is not coming from inside of the plane mirror. This light ray is the reflected light ray of this. But for a person who is looking at this light ray coming towards his eye, he would see that this light ray was coming from inside of the convex mirror from a point called F on the principal axis. So if I extend this line, and if I extend another dotted line from the pole, this is the focal length. This is the focal length. We call it as simple F. Right. Did you understand these two diagrams, guys? Are you okay with these two diagrams? Hello.
Yeah, sir.
Right. Anit Kattiya, how about y'all other guys? Are y'all okay with these two diagrams? Right. Everything has to be in order. So I want you to name this also as principal axis. Name this also as principal axis. Okay. Right. Shanuki, was it clear to you?
Yeah, sir, it was clear, but I'm not done with drawing.
Yeah, you can do it. Right. Ellie, was it clear to you? So under first right under concave mirror, right? Concave mirror, this mirror, okay, this mirror. Concave mirror converges, concave mirror converges, concave mirror converges, concave mirror converges. A parallel beam of light, concave mirror converges a parallel beam of light. Concave mirror converges a parallel beam of light. After the reflection, concave mirror converges a parallel beam of light after the reflection. At point F, F means the focal point. At point F, on the principal axis. At point F on the principal axis. At point F on the principal axis. At point F on the principal axis. A concave mirror converges a parallel beam of light after the reflection at point F on the principal axis. Point F in the principal axis go there. Okay, right. So then the next point for concave mirror. So since this converging effect of the concave mirror, right, like this, concave mirrors are called converging mirrors. 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 Okay, next. Concave mirrors are called converging mirrors. So go for the convex mirror. Convex mirror on this side, right? Convex mirror, right, like this. So what can you see in the convex mirror? The parallel light ray got diverged. Okay, here the parallel light ray got converged. Okay, this light ray got diverged. For convex mirror, right? A convex mirror. Sorry. Yeah, a convex mirror diverges a parallel beam of light. A convex mirror diverges a parallel beam of light. A convex mirror diverges a parallel beam of light after reflection. After reflection, as the diverged rays, as these rays are appears to be coming from a point inside the plane mirror called F on the principal axis. Okay, so we are going to write that point. A convex mirror diverges a parallel beam of light as the diverged rays, appears to be coming from the point F on the principal axis, appears to be coming from the point F on the principal axis, appears to be coming from the point F on the principal axis in front of the plane mirror. In front of the plane mirror.
Sir, repeat करेंगे.
Hurry. A convex mirror diverges a parallel beam of light as the diverged rays appears to be coming from a point F on the principal axis inside the mirror. inside the mirror. And next point for the convex mirrors. Convex mirrors are called diverging 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 mirrors. Right. That's it about convex mirrors. And then we have to talk a little more about the concepts of this one. Shanivi, can you read this for me?
The local point of spherical mirror is
Focal point.
situated at
Focal point.
oh, sorry, sir. The focal point of a spherical mirror is situated at the midpoint on the line connecting the pole, the central of
The pole and the
survey,
center of curvature.
curvature. The distance
Curvature. Right.
between the
Hold on. So can you remember this curved surface? Okay, but now you should remember this. Can you remember this curved surface was obtained from a sphere? Okay, this curved surface was obtained from a sphere. Okay, I'm gonna erase it. Okay, this whole curved surface was obtained from a sphere. Hope you can remember it. Okay, okay, back to the sphere that from which this curved surface was obtained. Okay, right? This curved surface was obtained from a sphere. Okay, so can you remember? Can you remember from the center of curvature? From the center of curvature of this sphere. Now, what I'm telling you? This concave surface was obtained from a sphere, and from the center of the sphere, we drew a line to connect the pole of the concave mirror. The center of the concave mirror is known as what? Pole. So the center of this whole sphere was connected by a line, hold on, by a line to the center of the concave mirror. This was called pole. Can you remember? It is called pole, right? Then this whole thing, this has to be a bigger version of the sphere. Hold on. It has to be a little bit bigger. Okay, right. Right. So what did we do? This concave surface was obtained from a sphere. Sphere had this point called center of curvature. Say from the center of curvature, there was this line coming to the pole of the curved surface. This was called the principal axis. Can you see that the point therefore the focus is located on the principal axis? Can you see that? Focus is located on the principal axis, right? It's exactly, now you call this length, in mathematics you call this length as radius, you call this length as radius. So exactly in physics, this focal point of the concave mirror is located at the half of the radius. That means when you go twice the length of the focal length, you would find the center of curvature of the sphere. Did you get it? Right? ඒ කියන්නේ මේ mirror surface එකේ ඉඳලා pole එකේ ඉඳලා focus එකට තියෙන දුර වගේ twice දුරක් ගියාම what හම්බ වෙනවා? Sphere එකේ center point එක. Can you understand? Put up your hand those who understand that. Right. Okay. So simply I can tell you, right? Shehara innawada? Shehara innawa නම් ඇයි දරුවෝ කතා කරන්නේ නැත්තේ? හොල්මන? Right. So you can simply say that focal length එක වගේ දෙකක් equals c. So if you can remember the length from the center of the curved surface called pole, the length from the pole to the focus, the length from the pole to the focus was called focal length. ඔය වගේ twice distance එකක් තියෙනවා from the curved surface to the center of curvature. මේ curved mirror surface එකේ pole එකේ ඉඳලා focal length දෙකක් දීපුවාම ඔයාලට හම්බ වෙනවා මේ මුළු sphere එකේ. ඒ කියන්නේ මේ curved surface එක belong වෙන sphere එකේ center point එක. So you can simply say focal length දෙකක් equal to C. Focal length දෙකක් equal to C. Okay, right. Shall can you read it? This one, Sharabi. Hello.
Sorry, sir. My mic was muted all this
Ah,
time.
right. Okay. Okay.
The distance between the pole and the focal point is known as the focal length of the spherical mirror.
You
The
have to
distance
highlight that.
between-
You have to highlight that. The distance between the pole and the focal point is called the focal length of the spherical mirror. I just mentioned it in the above two diagrams. Okay. Right. Thereafter,
The distance between the pole and the center of curvature is known as the radius of the curvature of the spherical mirror.
yeah. So
The
the distance from here, the distance from the curvature to the pole is called, in mathematical you call it as the radius, right? And then they tell us focal length, there will be twice the length of a focal length to the distance from the center of curvature to the pole. That means when you calculate two focal lengths, you could reach from the pole to the center of curvature of the curved mirror surface, right? Okay, read it, Uta Sharuki. This one, the radius of the curvature is R, is exactly twice the focal length.
The
That
radius.
means capital C is equal to 2 simple f. Okay, so then what you have to understand, what you have to understand here, this is a very important thing. It's extremely important when you're doing the ray diagrams. So what you have to understand here, if from the curved mirror, if you have like 2 centimeters from the curved mirror surface to the focal point, if you have 2 centimeters to the focal point, the distance from focal point to the center of curvature, that means to point C, would also be 2 centimeters. Okay, so the total distance from the center of curvature to the surface of the mirror would be 4 centimeters. That you have to keep it in your mind thoroughly, right? So the distance from the curved mirror surface at the pole, from the pole to the focal point, if it is 2 centimeters, the distance from the focal point to the center of curvature of the mirror would be also 2 centimeters. So there will be altogether 4 centimeters from the pole to the center of curvature of the curved mirror. It could be this or even this, for both the same. Can you understand that part? Now I
Yeah,
was
sir.
it clear? Right. Okay. Right. Right. Okay. Shall we next part?
Sir, the next heading.
Yeah. Yeah. Reflection from a
Reflection
concave
from
mirror.
a concave mirror. When
Right.
the rays come towards the concave mirror along the principal axis, the light ray strikes on the mirror perpendicularly and get reflected back on the same path.
Right.
Um,
So can you remember when we were talking about plane mirrors, what did we first do? We first figure out the laws of reflection on a plane mirror. We discovered how the light rays would behave when light rays comes in different ways to the plane mirror. We actually had two situations: a light ray coming perpendicular to the surface of the plane mirror, and what would happen to that light ray, and what will happen to a light ray which strikes on the plane mirror angularly. We had two laws to learn. Thereafter, after learning all those situations of light rays reaching the plane mirror and how would they get reflected afterwards, what did we do? We took a point object in front of the plane mirror. We took a point object on the plane in front of the plane mirror, and then we consider how would the image be formed after the reflection of light rays by the plane mirror. So then afterwards, now after knowing all the possible light rays behave after striking on the plane mirror, we kept a point object in front of the plane mirror, and then we tried to figure out how the image is created, right? Likewise, now we know how the light rays would behave with curved mirrors. So then what we are going to do, we have to learn few more things about how the light rays would behave with concave mirror. And then afterwards, we're going to keep an object in front of the concave mirror. And then let's figure out how would the light rays get reflected by the concave mirror and an image would be formed. So before that, we have to learn few things. How would the light rays behave when they are striking on a concave mirror surface? Now, the first thing what they say us is, if there was a light ray reaching the concave mirror surface, okay, if there was a light ray reaching the concave mirror surface, I would draw the principal axis with a green color. So if there was a light ray reaching the concave mirror surface perpendicularly, as I told you, use the red pen to mark the reflected rays and use the blue pen to mark the incident rays, right? So if there was a light ray coming along the principal axis to the concave mirror, that light ray would get definitely incident on the curved mirror, concave mirror with a 90-degree angle. Here the incident angle is 0, so therefore reflected angle also has to be 0. This light ray should get reflected back along the same pathway. First law. If there was a light ray reaching the concave mirror surface along the principal axis, it strikes on the plane mirror with a 90-degree angle. At that time, incident angle is 0, so the reflected angle should also be 0. The light ray gets reflected back along the same pathway. Rule number 1. Rule number 2. Okay. Rule number 2. Shanuki, can you read it?
Yes, sir. When the light rays come towards the concave mirror parallel to the principal axis,
Right. Okay.
the light rays.
Perfect. That's enough, Shanuki. So there is a light ray coming to the concave mirror parallel to the principal axis. So this light ray comes to the concave mirror parallel to the principal axis. Now you know what would happen to this light ray. It gets reflected. It gets reflected through a point called focus on the principal axis. Through a point called focus on the principal axis. Now what happened? There was a light ray coming towards the concave mirror surface parallel to the principal axis. That light ray, after getting reflected, that got reflected through the principal axis on a through the principal axis through a point called focus. Right. Third one is the reverse of this. Okay. Now see here, third law is the reverse law of this. Now in this situation, what did we have? We had a concave mirror and there was a light ray reaching the concave mirror surface parallel to the principal axis. Parallel to the principal axis, there was this light ray reaching the concave mirror. After that, the light ray got reflected and went through the focal point. Then light ray, you have the focal point over here. Then may light ray ka mirror surface eකට see here. Then may light ray ka mirror surface eකට through the focal point. Through the focal point තමයි mirror surface එකට එන්නේ light ray. Incident ray එන්නෙම through the mirror, through the focal point. Okay, so this light ray reaches the mirror surface through the focal point. So after that, the light ray gets reflected parallel to the principal axis. Parallel to the principal axis. Make a opposite එක, right? Make a light ray came parallel to the principal axis after the reflection went through the focal point. Ekame opposite එක තමයි make a light ray comes through the focal point and after the reflection goes along the goes parallel to the principal axis. Was it clear to you all?
Yes, sir.
Right. Okay. Next part.
So the fourth one, right?
Yeah.
When light rays come towards the concave mirror through the center of the curvature, the light strike on the concave mirror perpendicularly, so rays reflect. So rays are
On the same.
reflected along the same path.
Okay. Right. Now this is the fourth rule. Fourth rule. See here, if you can remember, right? Now you have the concave mirror surface. If you can remember, this was the principal axis, right? This was the principal axis. Okay. Can you remember the point F? The distance from the mirror surface to the point F is, imagine that was 2 centimeters. and from the point F to the point C also has to be 2 centimeters. Can you remember? C කියන්නේ the midpoint around which this sphere is created. C කියන්නේ the midpoint around which this sphere is created. මේ sphere එකෙන් තමයි මේ concave surface එක අපි obtain කරගත්තේ. Can you remember? At the very beginning. එතකොට මම කාගෙන් හරි ඇහුවොත් what is this straight? මෙහෙම line මෙහෙම ඉරක් ඇන්දොත් what do you mathematically call it? Radius නේද? What do you mathematically call it? Radius නේ ඔකට කියන්නේ ඔයගොල්ලෝ mathematics වලින්. So mathematically මේ radius එක නම් මේක mirror surface එකත් එක්ක incident වෙන්නේ with sort of an angle perpendicular. Can you remember? As I told you, radius touches the circumference of a circle with a 90-degree angle, right? So එහෙනම් මේකත් මොකද්ද? දැන් මේන line එකද? ඉතින් ළමයි මේකත් බලන්නකො මේ තියෙන්නේ F කියලා හිතන්නකො. මේ තියෙන්නේ 2F. ඒ කියන්නේ capital C. මෙතන ඉඳලා මෙතන තියෙන්නේ radius එකක් නේද? Right? If it for the circle මේකත් radius එකක් නේද? Then now what they say මේ මම දැන් කියන්නේ if you draw a line from the C, from the point of curvature, center of curvature to the surface of the mirror. The mirror surface will be touched by this line with a 90-degree angle. Ehena now they say there is this light ray coming towards the make a තේරුණාද? මේක තේරුම් ගන්න යතෝ සර්. Shanti was dropped. Bimsen මේක තේරුණාද?
No, sir.
තේරුන්නේ. Right, okay. In the හරි. හරි. Right. හරි. මෙන්න තියෙනවා concave mirror surface එක. මේ concave mirror surface එක. හරිද? මෙන්න principal axis එක. මෙන්න principal axis එක. Right? මම මේ principal axis එකේ මේ mirror surface එකේ ඉඳලා හිතන්නකො 2 cm කියලා. එතනින් මාක් කරනවා F එක. focus කියන එක. ඊට පස්සේ ඔතන ඉඳලා තවත් 2 cm වලින් ඈත තමයි මොකද තියෙන්නේ? C කියන එක. ඒ කියන්නේ 2F කියන එක. ඇයි මෙතන ඉඳලා මෙතනට තියෙන length එකට අපි කියන්නේ focal length කියලානේ. දැන් මේ point එකට කියන්නේ capital F ඈ. මේ length එකට කියන්නේ focal length, simple F කියලා. එතකොට simple F ඒවා දෙකක length එකක් තමයි point C එකට තියෙන දුර. මෙතන ඉඳලා. හරිනේ? right. ඕක තේරුණාද වින්සෙන්?
Oh, sir.
හරි. ඊට පස්සේ ඔන්න දැන් හැමෝම අහගන්න උපේක එක තේරුණාද?
Yes, sir.
right. චනුකී එක තේරුණාද?
Yes, sir.
okay. දැන් මම අඳිනවා මේ curve mirror එක ගත්ත මේ curve mirror එක මම ගත්ත sphere එකකින් මතකනේ at the very beginning මම මේ mirror එක complete කරනවා. sorry. sphere එක complete කරනවා. මෙයාව ගත්ත sphere එක. හරිද? මේක center point එක කියලා හැමෝටම තේරෙනවා. this is the center point. center of curvature. මෙන්න මේ කැලේට ඔයාලා ටෙක්නිකලි කියන්නේ මොකද්ද? මේ length එකට maths වලදී කියන්නේ මොකද්ද? බීමා
Radius.
දැන් මම ඔයාලට කලින් කියලා දුන්නානේ radius එක මේ mirror surface එක touch කරන්නේ perpendicular කියලා දුන්නා නේද? බීමා කියලා දුන්නා නේද මම එහෙම?
Oh,
හරි. එතකොට බීමා මේකට මොකද්ද කියන්නේ? මම මෙහෙම එකක් අඳොත් ඒකට මොකද්ද කියන්නේ? maths වලින්
radius.
ඒත් radius නේද? තේරුණාද ළමයි? මේකත් ඒ ඉතින් center point එකේ ඉඳලා circumference එක touch කරනවා නම් ඒක radius නේද? Shanaki, was it clear? Upeka, is it clear?
Yes, sir.
Virginia Ratnaseka, is it clear?
Yes, sir.
Yeah. Right. Okay. එහෙනම් මෙයා touch කරන්නේ mirror surface එක with a perpendicular. තේරෙනවද? බීමා හරිද?
Yes, sir.
හරිනේ. එහෙනම් මම දැන් මේ ස්පියර් එක මකනවා. දැන් ඔයගොල්ලෝ ප්‍රශ්නේ විසඳුවානේ මම එහෙනම් මේ ස්පියර් එක මකනවා. මිරර් එක විතරයි තියෙන්නේ. මිරර් එක විතරයි දැන්. මිරර් එකට if there was a light ray coming through center of curvature. mirror surface එකට light ray එකක් එනවා දැන් center of curvature කියනවා. දැන් ඉස්සරලා light ray එක ආවේ mirror surface එකට focus එක through ඈ. දැන් light ray එකක් ඉන්නේ mirror surface එකට center of curvature එක through. බිමා තේරෙනවද දැන් ඔය එන light ray එක mirror surface එක touch කරන්නේ perpendicular එකකින් කියලා?
ඔව්.
එහෙනම් මෙතන වෙච්ච සිද්ධියම නේද වෙන්න ඕනේ බිමා? මෙතන incident angle එකක් තියෙන්න බෑනේ.
බෑ.
එහෙනම් reflected angle එකකුත්
නෑ.
නෑ. එහෙනම් ওই light ray එක reflect වෙන්න ඕන කොයි පැත්තෙන්ද?
same path.
same path. චනකේ තේරුණාද? උපේ was it clear? නිර්මාණි පුතේ හරිද?
Yes, sir.
නිර්මාණි හරිද?
Yes, sir. Ma'am.
හරි. ශනුකි හරිද?
Yes, sir.
right okay. පහක් තියෙනව නේද ශනුකි ඔකේ? තව එකක් තියෙනවනේ.
Yes, sir.
right. ඊළඟට මේ වගේ තියෙනවා curve mirror එකක්. ඒ කියන්නේ concave mirror එකක්. මෙන්න principal axis එක. මෙන්න principal axis එක. incident ray එකක් තියෙනවා angularly. එහෙම නේද? කියලා තියෙන්නේ එහෙම නේද? fifth one.
So should I
Yeah,
read
yeah,
it
can you?
again?
Yeah.
When the light rays strike on the concave mirror with an angle of
Right.
immense with the principal axis, the rays get reflected back with an equal angle of reflection.
Right. So you have the principal axis. There's this light ray incident on the concave mirror with an angle of incidence. Then angle of incidence theta. Then more than note. Method according to the reflection law, angle of incidence has to be equal to the angle of reflection. එහෙනම් මෙයා reflect වෙන්න ඕනේ with a similar angle like the incident angle. තේරුණාද කතාව? Was it clear, guys?
Yes, sir.
Right. So from the right beginning, we have to know all of those laws. මොකද මෙතනින් එහා පැත්තට අපි මේ හැම අපි මේ concave mirror එක ඉස්සරහා we will be keeping objects and we would see how the image we formed after light getting reflected back from the concave mirror. So you need to know them well, right? So first one, law number one. If you have a concave mirror surface, if there was a light ray reaching the concave mirror surface along the principal axis, the incident ray strikes on the plane mirror with a perpendicular and then incident angle will be 0. So according to the laws of reflection, reflected angle also should be 0. So as a result, the light ray would get reflected back along the same pathway. Number two, if there was a light ray, incident ray reaching the concave mirror parallel to the principal axis, the light ray after the reflection after the reflection goes through point F on the principal axis. So if a parallel light ray reaches the principal axis, the light ray gets reflected and goes through the principal axis at point F. The reverse of this is this. If there was a light ray reaching the concave mirror surface through the focal point, the light ray would get reflected parallel to the principal axis. Here the light ray came to the mirror surface parallel to the principal axis and got reflected through the focal point. Here the light ray comes to the surface of the mirror through the focal point and it gets reflected parallel to the principal axis. The fourth one, if there was a light ray reaching the concave mirror surface through the center of curvature. Now what is the center of curvature? The center point from which this entire curve mirror, the concave mirror, was created. So this light ray reaching the center, light ray reaching the concave mirror through the center of curvature is similar to the radius of a circle. Okay, so any radius reaches the circumference with a perpendicular, which means this light ray coming to the concave mirror surface through the principal, through the center of curvature this light ray, incident ray reaching the concave mirror surface through center of curvature, incident on the curved mirror surface, incident on the concave mirror surface with a perpendicular, which means incident angle here is 0. So according to the laws of reflection, reflected angle also has to be 0. So this light ray also gets back along the same pathway after the reflection. Fifth one, if there was an incident ray reaching the concave mirror surface with an incident angle, with same sort of an angle, the light ray would get reflected away from the mirror, right? So this is how the 5 laws would be. Quickly note them down at specific points, okay? So here you have the specific points. May palavini එක here. Second thing and third thing, likewise note it very clearly. Yeah.
Sir,
Oh, පුතේ අහන්න.
sir, Roman number 5 එකේ අර ray එක වැදෙන තැන පෝල් එකක් වෙන්න ඕනේ නේද?
රේක වදින තැන පෝල් එකක් වෙන්න ඕනේ.
හරි.
හැබැයි මෙහෙමයි. රේක වදින තැන පෝල් එකක් වෙන්න ඕනේ නැහැ. ඔයා කියන එක ඇත්ත. හරි. That's true. But අපි මේ සිලබස් එකේ උතන ඔයා කියන එක හරි. පෝල් එකක් වෙන්න ඕනේ නැහැ. ඕන තැනකදී ඔයගේ රිෆ්ලෙක්ෂන් එකක් වෙනවා. කර්ව් මිරර් සර්ෆස් එක ඕනේ. අපි හැබැයි අපේ සිලබස් එක කන්සිඩර් කරන්නේ පෝල් එකට ඔහොම වදිනවා කියලා තමයි. හරිනේ? බිම හරිනේ?
හරි sir.
Okay.